Now this is question 2a. We are asked to simplify x squared positive 7x divided by x squared negative 49. Now I can rewrite the numerator as x of x positive 7. So we can take an x out. The denominator x squared negative 49 is of the form a squared negative b squared. Now this has a formula a negative b multiplied with a positive b. So therefore x squared negative 49 is going to be x squared negative 7 squared, which is going to be x negative 7 times x positive 7. So over here this is going to be x negative 7 multiplied with x positive 7. So x positive 7 gets cancelled, giving us x over x negative 7. So this is a solution for this question. Okay, this is question 2b. What they are asking us is to find the value of r such that you have got x squared multiplied with x raised to the power of 6 is equal to x raised to the power of r. Now we have to use the law of indices. Okay, so please go through my notes on law of indices, the different laws I have given there, along with the worksheet, and solve examples. Okay, now from the law of indices, we know that a raised to the power of m multiplied with a raised to the power of n is equal to a raised to the power of m positive n. So we know this formula. So hence x squared multiplied with x raised to the power of 6 is rewritten as x raised to the power of 2 positive 6, which is going to be x raised to the power of 8. Now let me take this as 1. So therefore I can rewrite 1 as, in place of x squared times x raised to the power of 6, I'm going to write it as x raised to the power of 8. And that is equated with x raised to the power of r. Now again, by the law of indices, we know that. WKT stands for we know that. What do we know? If a raised to the power of m is equal to a raised to the power of n, if the bases are same, then the exponent value is equated. Okay, so if I were to take this as 2, therefore 2 can be rewritten as r is equal to 8. So we write it like this, r is equal to 8. Okay, so that is the solution for this question. Let's move on. Now this is the next question, section 2b2. Now they are asking us to find the value of s if s raised to the power of 3 is equal to 8. Okay, so this is a solution. Now what are we given? We are given s raised to the power of 3 is equal to 8. I'm going to rewrite this as a cubic power. So that should be a first idea. You observe the left side. The left side is a cubic power. So what you need to do is you need to convert this right side to a cubic power. How is that possible? It is possible because we know that 2 multiplied with 2 multiplied with 2 will give us 8. So therefore 8 can be rewritten as 2 raised to the power of 3. Okay, so because of the product multiple concept that we know already. So having mentioned that, I now rewrite a x cubed equal to 8 as x cubed is equal to 2 raised to the power of 3. Now, in most cases, you will actually see a more complex form of this question. But in this case, it is very simple. But what I'm going to show you is, no matter whether it is complex or it is simple, you can adopt this technique. So what is this technique? Your technique is to get rid of this 3 that you see as an index for the base s. I want to get rid of this first. So to get rid of this first, what do? I raise both sides to the power of 1 over 3. So you do that. You raise both sides to the power of 1 over 3. So let me move to the next slide. So continuing on, I just mentioned to you that given x cubed is equal to 2 cubed, my objective was to raise or get rid of this 3. So for that, I told you all that we need to raise this to the power of 1 over 3. Now why do I do that? Let me show you that. So there's going to be 2 raised to the power of 3, which is going to be raised to the power of 1 over 3. Now from the law of indices, if you have a raised to the power of n and you are raising it to some 1 over m, you can rewrite this as a raised to the power of n into 1 over m. So this is the property that is available. Now why did I place m here? M can be any value. It can also be equal to n. It can be a value which is not equal to n. So that's the reason I just mentioned to you. So no matter what the power that you see here, you can actually multiply it with the power that is present out and it is appearing as a rational quantity. So that being said, I'm going to rewrite this as s raised to the power of 3 multiplied with 1 over 3 is equal to 2 raised to the power of 3 multiplied with 1 over 3. So this is what we've got now. Now clearly you can see here, since there is a product here, I can cancel the 3's. So what is left here? We have s is equal to 2. So that is the value. Now I know that some of you all would say that why the exponents are same, the base can be equated. Of course, there is a point on that case also. But as I mentioned to you at the start of this question, most times the variety that we see will be little bit complex. In other words, the exponents will be of different values or different varied magnitudes. So this technique caters to all. So let's move on to the next one. Okay, let's move on to 2C. Now we are given this question. The diagram below shows a triangle and a quadrilateral. All angles are in degrees. That's important. And are written in terms of A and B are, so this is what is given. So you have a triangle and a quadrilateral. Okay, now we have this 3b and this one is a positive 2b and this one is a positive 9. Now for the triangle, show that 2a positive 5b is equal to 171. So we have to prove, or we have to show the result. Okay, so let me answer this question first. So you have 3b and a positive 2b and you have a positive 9. So let me name it as a, b and c. So this is a solution from geometry, or from the laws of geometry. Sum of the angles in a triangle is equal to, they add up to 180. So this means 3b positive a positive 2b positive a positive 9 is equal to 180. You add 3b with 2b, that's 5b, and a with a, that's 2a, and you have a 9 that is equated to 180. Move this 9 to the other side, 180 negative 9. So you have 2a positive 5b is equal to 171. So we are expected to solve that. So let me solve that. So you have 2a positive 5b is equal to 171. I'm going to take that as 1. Now you comparing 1 to the given. So what is given? Given is 2a positive 5b is equal to 171. So write that. To the given 2a positive 5b is equal to 171. We observe that they are same, or you can use the word, equal. So this means we have proved, hence proved. Okay, so that ends the solution for this question. So the next part, so let me move to the next part. The next part is asking us for, this is part 2. So 2C part 2. So for the quadrilateral, show that 7a positive 8b is equal to 342. Okay, so let me draw the quadrilateral for y'all. Okay, so this is the quadrilateral, and you have the following: 6a, this is 18b, or I would say 18, no b there, 18 positive 3b, and then this is 3b minus 2a, 3b minus 2a, and this is 3a positive 2b. So what do we know for the quadrilateral? From the law of geometry, we know that WKT stands for, we know that what? Sum of the angles. Say if I were to take this as A, B, C, D, we know that angle A, positive angle B, positive angle C, positive angle D is 360 degrees. So this means 6A positive 3A positive 2B positive 3B minus 2A positive 18 positive 3B is equal to 360. So you add all the A's. This is 6A with 3A, 9A. 9A, you take away 2A, you get 7A. And then 2B plus 3B is 5B. 5B added with 3B is 8B. And then you have 18 here, so you got to push the 18 to the other side. So 360 negative 18. So from 360 you take away 18, you carry 110, from 10 you take away 8, you get 2, from 5 you take away 1, you get 4, so that's 342. So you have 7A positive 8B is equal to 342. Now this is 2. Now we have to take this and compare it. Comparing to with the given, we observe that, what do we observe? We observe that, see here, okay, so it's over here. We observe that 7A positive 8B is equal to 342. That's exactly what we got. We observe that they are one and the same, or you can write equal. So this means, hence the result is proved. Okay, so that's the solution for this question. Okay, this is the next part. This is 2C section 3. They are asking us to solve the pair of the simultaneous equations that we just got of 1 and 2. So when we talk about 1 and 2, We are talking about 2a positive 5b is equal to 171. This is 1. And then 7a positive 8b is equal to 342. So we are expected to solve these two. Now what I'm going to do is I'm going to multiply 1 by 7 and 2 by 2. 7 multiplied with 2, that's going to be 14a positive 35b. 7 ones are 7, 7 7s are 49, 4, 7 times 1 is 7 and you have 11. So 2 times 7, that's 14a positive 16b is equal to 2 times 2 is 4, 4 times 2 is 8, 3 times 2 is 6. Change the sign, change the sign, change the sign. These two gets cancelled. So from 35 you take away 16. So what do you get? You get 9, right? So from 2 you take away 1, you get 19 there. So you have 19b there. Then 1197. From 1197 you have to subtract 684. From 7 you take away 4, you get 3. From 9 you take away 8, you get 1. From 11 you take away 6, you get 5. So this is 513. So therefore b is equal to 513 divided by 19. Now the question is, can we divide 513 by 19? Now let me try 7. I'm not sure, but I'm going to try 7. Okay, what we do is we can actually reduce it first. So 9, I'm going to place 2 here. So this is 9 times, or I would say 19 times 2 is 38. So you carry 1, 8, 9, 10, 11. So you have a 3 there. And you already have 4 there. From 4 you take away 3, you get 1. So 133 is there. Now let me place 7. 7 into 9. 7 times 9 is 63. Carry 6. 7 times 1 is 7. 700 with 6 is 13. So that's a perfect division. So the value of b is 27. So clearly you can see that this is a huge number. Okay, now, okay, so that's a working part. Now what I'm going to do is I'm going to substitute b is equal to 27 in 1. So what is 1? 2a positive 5b is equal to 171. So this is 2a positive 5 times of 27 is equal to 171. This is 2a positive 5 multiplied with 27. 5 times 7 is 35, carry 3. 5 times 2 is 10. You get 3 there. So 135 is what we have got. So it's 171. Push this 135 to the other side. 171 negative 135. So from 171 you take away 135. What do you get? You have 11. From 11 you take away 5, you get 6. From 6 you take away 3. You get 3 there. So this is 36. And you have 2a there. So therefore a is equal to 36 divided by 2. 2 divides 18 times. So a is equal to 18. So this is what you got. So a is equal to 18. Now you can go forth and perform one more thing. So you can do the check. So what I'm going to do? I'm going to do a check. So 2 times a is equal to 18 and b is equal to 27. You substitute these two, you should get 171. So this is 36 positive 5 times b of 27. 7 5s are 35. 3 5 times 2 is 10. 11 12 13 is equal to 171. So you add these two together, you should get 171. 6 added with 5 is 11. You carry 1. 3 plus 3 6 added with 1 is 7 and you have 1 there. So 171 is equal to 171. Therefore check is true. Check is true. And what is the solution set? Solution set is a is equal to 18, b is equal to 27. So you box this and show it to the examiner. Now of course this is not, check is not required, but this check really ascertains the fact that your values are correct. Now another important fact you need to know, that by doing all these things you are impressing the examiner, right? So that means you are showing to the person who is examining you that your domain knowledge is complete. Okay, so these things are all add up. as proof of your competence. Okay, let's move on to the next one.